Hello students. So today in this lecture we are going to discuss about classification of stainless steel. Steel to be precise. Now when classify steel or stainless steel for that instance, or the other different phases of stainless steel are formed mainly because of the amount of carbon present in them. And the next is the temperature. Now, based upon the amount of carbon, if you say so, you can classify steel based upon the amount of carbon into mainly three types: A, B, and C. The first one is called low carbon steel. Low carbon steel, where the carbon concentration is between 0.08 to 0.3%. Zero point zero 0.08 to 0.3%. These are called low carbon steel. The second is called medium carbon steel, where the concentration is between 0.3, that is the end of low carbon steel, to 0.5%. And lastly, we have high carbon steel, where the concentration is from 0.6% to 2%. From 2% onwards, it becomes the cast iron, so it no longer remains the steel. So these are the three classifications made based upon the temperature. Now, uh, next is the microstructure of pure steel. The microstructure. Say of the three different steels. First one is also called low carbon steels, are also called mild steels. Or if in fact mild steel is another classifications where the concentration is below 0.08. Then you have low carbon steels. High carbon. In fact, there are some places where the low carbon steel that we have just talked about, they are called, instead of low carbon, they are called mild steel. The medium carbon steels are called low carbon, and the high carbon steel as it is. So, in fact, it's all about between 0.08, the lowest carbon concentration, which can make an iron a steel. This is the lowest one, to 2%, below which we call it as cast iron. This is the range of carbon concentration possible in steels with different names. In fact, if in the iron, if E3C phase diagram, from 2% onwards, the maximum, there are other cast iron, they consider the cast iron. So the 6.67% of carbon is the end of the phase diagram. We cannot have anything beyond 6.67%. And all these, so we get actually different allotropes of carbon, and so let's write it once again in 0.08, sorry, 0.08% to 2% is one classification, while you are getting the different phases of stainless steel from 2% onwards to 6.67 percentage. We get cast iron. Sorry, this is where you get cast iron, and from 6.67 till 6.67 percentage you are getting this cast iron. So this is the end of Fe3 diagram. So different allotropes of this of carbon of Fe3C are formed here, and the changes that are taking place due to this percentage of carbon and temperature when there is a change in the crystal structure. So let's discuss some of the changes that are taking place. Like the first change that can be considered is when say at 252 Fahrenheit F, there is a change from the BCC phase to FCC phase. Okay. Similarly, so this is the first one. Similarly, at 1400 Fahrenheit, a plateau is observed, and this does not signify, it is not signifying a phase change, but there is a transformation from austenite to ferrite plus Fe3C, which is called cementite, and this temperature is called the Curie temperature. So at this Curie temperature, there are some important changes taking place. So let's say at Curie temperature, there is a transformation that takes place, from 0.83 percentage of carbon, uh, which is called the eutectoid transformation, or where there's a formation of perlite, and at 4.3 percentage of carbon, which occurs at which is actually eutectic transformation. Which is occurs at a temperature of 2066 Fahrenheit. So this polarity transformation is what that has been told in the previous case. That means there is austenite transforming into ferrite plus cementite Fe3C, whereas at this transformation there is a change. It is called ledeburite, transformation, where from the liquid state there is a transformation to austenite plus cementite. This is called eutectic transformation. So eutectoid system or a eutectic transformation is one where a single phase solid it transforms into two-phase solid. Like a single phase solid means, taking the previous case, it was austenite, and it is converted into perlite, which is alpha, where these two phases are coexisting. This is called eutectoid transformation. So if there are two classifications of this eutectoid. First one is known as hypereutectoid, and the second one is hypoeutectoid. So from the name itself you can understand a hypereutectoid is a system which exists below the eutectoid temperature, whereas a hypereutectoid system exists below the eutectoid temperature, hypo and hyper. Now this alpha or this ferritic phase that we recently discussed, this alpha, this is the ferritic phase, ferrites, also known as alpha. So it has a BCC phase, whereas this austenite, it has an FCC phase. We have other phase irons as well, like we have delta iron, which is again BCC phase. So it exists at high temperatures where austenite, which is supposed to be the stable form at lower temperatures, it no longer is the stable phase of iron. It is basically at high temperatures. So the temperature range of this delta iron is 2802 to 2552. So initially 1400 was, or the Curie temperature was considered to be the stable phase of argon, where there was no exact phase transformation take place unless and until there was any carbon change. So the phases started to form and there was a percentage carbon change from 0.83 0.083 as mentioned previously. Now the Eutectic transformation that brought from austenite to alpha plus alpha 3 where these phases coexist. It is called pearlite. So basically it is a lamellar structure where you have this alpha phases coexisting with this Fe3C phase, lamellar structure. Now cementite or this Fe3C phase, this forms beyond 2% of carbon, where it is assumed that the carbon is in excess of the solubility limit. This cementite phase is formed. Next is your ledeburite phase. It is actually considered the eutectic form of cast iron CS, where this 2% more than 2% carbon percentage more than 2%. So particularly this phase, this is considered to have 4.3 percentage of carbon in combination with argon. So apart from these transformations, there are other classifications basis. So other classification basis that exists, other classification basis as well, and these classifications are made based upon the firstly the amount of other elements apart from carbon. The method of manufacturing, and the form use. So we will take up these in the subsequent lectures.